Well, hello folks, and welcome to the channel. As you may or may not know, I love my retro hardware, but that is no excuse to be running not far off vintage hardware as my UnRaid server. So, in this video we are going to be taking a look at this glorious hardware that is going to be replacing my current UnRaid setup. This is an ASRock X9DAL-i Phantom Gaming 6 motherboard with support for socket TR4 AMD Ryzen ThreadRipper X series processors. Currently installed and tested, we have a first generation ThreadRipper 1900X, an 8-core 16-thread CPU, launched in August 2017 with an MSRP of $549. The 1900X is built on a 14nm production node using 9,600,000,000 transistors and has a 32MB level 3 cache and operates at a base clock speed of 3.8 GHz and can boost up to 4 GHz. We are not going to be using the 1900X because I have a Ryzen ThreadRipper 1950x to install into this system, a 16-core 32-thread processor, also launched in August 2017 but with an MSRP of $999. The 1950X also has a 32MB level 3 cache and operates at a base clock speed of 3.4 GHz and can boost up to 4 GHz. So after clearing off the old paste from the CPU and heatsink, first up we need to remove this ThreadRipper 1900X from the motherboard socket, and this is my very first time playing with this sort of hardware. To remove the processor, AMD provide this Ryzen torque wrench because the processor is bolted down by these 3 hex bolts that are numbered 1, 2 and 3. As we are removing this processor, 3, 2, 1 and it should be freed from the socket. And out she comes, and we are ready for the 1950X to be installed. A nice healthy blob of thermal paste. Remove the 2 fans first from this Noctua TR4 cooler. And you can see the bottom is nice and clean, almost like a mirror, which is good to see. Plop the heatsink on top, and I just give the heatsink a little wiggle around to help spread out the paste. After a couple of attempts, you can see that there are still a few little patches that are uncovered. So I'm just going to place a few little spots on those areas, and we should be good to fasten down the heatsink. Once the tension goes down onto the heatsink, it should spread out the paste, giving total coverage of the processor. I wonder if this ThreadRipper torque screw fits these. Nope. Bad Noctua. Or AMD. Or both. You would have thought that these screws would have been a standardised size, but oh well, she's all fastened down nicely now. For memory, I will be using two 16GB Corsair Vengence LPX DDR4 memory modules, which is a slight downgrade from the 80GB of DDR3 that is currently installed in my UnRaid box, but for the time being I'm sure I can manage with just 16GB for my virtual machine. We attach the fans now to the Noxua heatsink, and that is the main components all installed and ready to run. I decided that with the upgrade to the hardware I should invest in a new PSU with a greater power output. I shouldn't really be using any more power than before. In fact, the processor will be using 10 watts less than the dual Intel Xeon E5-2440s that I've been using, with each CPU consuming up to 95 watts each. So I have gone for a Corsair CX650 PSU, nothing special, an 80 plus bronze rated PSU, and it has an output of up to 650 watts. The last piece of hardware that we will be installing is a graphics card, and I'm going to be using my spare Zotac GTX 980, and now we can finally attach the power to the motherboard and we should be ready to power her up. Right then, I know this board is working as I boot tested it with the 1900X, so let's give her some juice and see if we can get a picture.
Here we go.
And would you look at that beauty? AMD Ryzen ThreadRipper 1950X. And you can see that both 16GB sticks of memory are being detected, so yeah, I'm pretty stoked at the moment, which brings us on to a very much important question. Can this ThreadRipper play Doom? Well, let's find out. Doom timed 2,134 game ticks in 928 real ticks, which works out to approximately 80.49 frames per second. Well, I must say, that was a pleasure seeing Doom running on this ridiculous system. I was half expecting it to fly through that demo at a ridiculous speed, but it didn't, which was a surprise. While we are here in DOS, we might as well have a little gale at SpeedSys. And as expected, everything is off the charts. Processor is an AMD Unknown at 3394 MHz, memory size of 157 MB, which is a bit strange, with a memory bandwidth of 7559.06 MB, 16,384 KB Visa memory with a bandwidth of 54,165 KB per second. The processor score is off the scale, and the memory timings are as follows. The 512K data cache level 1 transfers 39,506.98 MB per second. That is pretty fast. And memory throughput is 27,062.16 MB per second. Silly numbers, but all looking good to me so far. So after that little bit of a laugh, the last component we need to install before the ending of this video is a 1TB Kingston NVMe SSD. It is not a particularly expensive SSD, nor is it particularly fast compared to others, but for me, it will be a big step up from the 120GB OCZ Agility 3 that I've been using for probably more than 10 years. That is the SSD mounted and installed into the socket, and the last piece of the puzzle now is the SSD heatsink, and that brings us neatly to the end of this video. In the next video we will be ripping apart my UnRaid box and installing this lovely hardware, and then we can start to actually rip some threads. I hope that you've enjoyed exploring the hardware of this project, and I thank you for watching and supporting my channel. It really is massively appreciated. Take care folks, and I'll see you soon.